research group is incredibly varied. It involves so many different aspects of engineering, mathematics, materials, and structures. And what we do is we take inspiration from nature and from engineering needs to create totally novel soft robotic solutions. They could be in wearable technologies, they could be in environmentally interactive robots, they could be in almost any aspect of robotics. But the bit that joins it all together is the soft robotic technologies. Those are the materials, the mechanisms, and then the machines that can really exploit the soft robotics. If you think about sociological problems and environmental problems, soft robotics can start to solve those. One is to do with the aging population and people who have got healthcare problems. If you have a disease which causes a degradation of part of your body internally or externally, you can use soft robotics as a potential technology to treat that disease. You could also use the technology to change the way in which we manage the environment. We have made devices where you can take them out into the environment and they can operate autonomously as robots. And when they finish, they degrade to nothing. The great thing about that is that you can use the same technology to make totally different kind of robots, like edible robots. We can make, and we're working on, edible robots. You eat it, it goes into your stomach, does something really good for you, it increases your efficiency of digestion, and then you just absorb it, and it disappears to nothing. That could be of great benefit to people who have problems inside their bodies, but also could be really useful for monitoring people's health as well.
We just recently started a project with biologists from Oxford into spider webs. And you look at the spider web, you can see that the structure is very, very complex. And we assume that the spider uses the web as some kind of signal processing device. So we're trying to look into real spun spider webs and understand what kind of computation is going on. And based on these insights, we're going to build sensors, for example, for vibrations or for flow. So we can put them on buildings to detect earthquakes, or on wind turbines to see if there's a failure coming along, or into tubes and measure the flow, for example.
Well, these are a type of electroactive polymer.
An extremely exciting and promising area of soft robotics is looking to biomedical applications. So making robotic systems that can interact safely with the body is really important for the material itself to be soft and flexible. A lot of the materials we use are smart materials which can act as actuators, so they apply electric voltage and they will move, but they can also sense. We're currently working on a soft robotic worm, which we have several biomedical applications we hope to use it for. But also think of things like earthquakes or any structural collapse, that these are robots that could potentially be distributed and they can squeeze and crawl through tight gaps to find people.
Another project that we're working on is rowing robots. So if you look at morphological computation, you understand that there's some intelligence in the body. So if you change the body, you basically reprogram the functionality in the body. And we try to explore that in this project by building a robot that grows from a tadpole into a frog. So there's a very strong change. And we try to understand how we can learn to use these different types of bodies from the history of their morphology and the growing process. And by doing that, we hope to get at the end a very flexible and robust robot. So if you cut off a leg, or it happens that something is broken, it would be immediately able to adapt itself to this new situation and would be able still to swim on or walk on without just having all the legs there.
Can you resist against it? Can you really push hard? We are challenging the sense of touch. We're challenging how people interact physically with technologies. Let me give you an example. One of the projects we're working on is to make robotic trousers. These power pants, as they will call them in America, would help you to move as you get older or if you have a disability. So just imagine that you needed to walk up a mountain or something like that. You could also use these power trousers. As you go up the mountain, these trousers will be giving you extra power and extra force to enable you to move and to move up to the top of the hill. Now these materials have got the capability whereby you put electricity in them, they generate movement and force, but also when you put energy into them mechanically, they generate electricity. So that means when you're at the top of the mountain and coming down the other side, you can switch your trousers into generator mode and generate electricity coming down the other side to charge your phone or to do something useful. My trousers are very dumb. My future trousers will be very smart.